Hello there. We are Group G5, the first year students from Vishwakarma Institute of Technology, Pune. Today, we are going to present you DMA, the mode of data transfer in computer organization and architecture. And this is my team. Have you ever thought how data is being transferred from computer to peripheral devices? This is so because of I/O subsystems. All input-output devices are slower than CPU and memory, and there are wide variety of peripherals having different speeds and deliver different amount of data. So there is a need of some input-output module which can be an interface between fast CPUs and slower devices. The method that is used to transfer information between internal storage and external devices is known as I/O interface. Data transfer to and from the peripherals may be done in three of the possible ways: programmed I/O, interrupt driven I/O, and direct memory access. Our today's concern is knowing DMA, that is direct memory access. After watching this video, learner will be able to know.
Greetings everyone. We are Group 5 from Vishwakarma Institute of Technology, Pune. This is me and my team, and we have collectively put together our efforts to demonstrate the working of direct memory access DMA. Moving to the content for today's presentation, we are presenting what is DMA, components of DMA transfer, working of DMA, modes of DMA transfer, 8237 DMA controller, and advantages and disadvantages of DMA.
Now we will see what does direct memory access mean. Direct memory access DMA is a method that allows an input-output devices to send or receive a data directly to or from the main memory by passing the CPU to speed up the memory operations. The main purpose of DMA is to improve the overall performance of the computer system. It reduces the burden on the CPU by allowing the peripheral device to transfer the data to and from memory directly. This frees up the CPU to perform other tasks which leads to faster and more efficient processing. For that purpose, we use DMA controller, which is a hardware device that allows input-output device to directly access the memory with less participation of the processor. DMA controller needs the same old circuits of an interface to communicate with the CPU and input-output devices.
There are four blocks of DMA transfer: DMA controller, CPU processor, memory, and input-output devices. DMA controller is a hardware device which allows input-output devices to directly access memory with less participation of the processor. It consists of three registers. First, address register. It contains the address to specify the desired location in memory. Then, word count register, which contains the count of how many words are read and written can be done by CPU. And the last is control register, which contains control signal, whether it is a read signal or a write signal. And all these registers are loaded by CPU through data bus. As we can see in the figure, there are so many components. The first, DS, that is device select, which is used to select the device. Register select, RS, which is used to select register. RD, read signal, and WR, write signal. BR, burst request. CPU has burst request pin, so that request sent by DMA to the CPU states that DMA is asking for a burst. BG, that is burst grant, which states that permission is granted and now DMA is a new burst master. And the last is interrupt. And there also consists buffer for temporary storage of information.
Hello guys, we are going to the working part of the DMA controller with the diagram. So this is the diagram of DMA transfer. Okay. So DMA controller has to share the bus with the processor to make the data transfer, and the device that holds the bus at that time, this is called the bus master. When transfer from input-output device to the memory or vice versa has to be made, the processor stops execution of the current process, increment the program counter, moves data over stack, then sends DMA select to signal DMA controller over the address bus. If DMA controller is free, it requests the control of bus from the processor by raising the bus request signal. Processor grant the bus to controller by raising the bus grant signal. Now DMA controller is the bus master. The processor initiate the DMA controller by sending the memory address, number of blocks of data to be transferred and direction of data transfer. After arising the data transfer task to the DMA controller, instead of waiting ideally till completed of data transfer, the processor resumes the execution of the program after retrieving instruction from the stack. Transfer of data by DMA in computer by DMA, and transfer of data in a computer by DMA controller, so that DMA controller now has the full control of buses and can interact directly with memory and input output device independent of CPU. If it makes the data transfer according to the control instruction received by the processor. After completion of data transfer, it disables the bus request signal and the CPU disables the bus grant signal, thereby moving control of buses to the CPU. So when input output wants to initiate the transfer, when it sends the DMA request signals to DMA controller, for which the controller acknowledge if it is free, then the controller requests the processor for bus raising the bus request signal. After receiving the bus grant signal, it transfer the data from the device, and for n channel DMA controller, n number of external devices are to be connected. So these are the system bus. When input output device is connected to our system, then the signal goes from input output device to DMA. It requests DMA for transfer, and then DMA holds to CPU, and then after hold the CPU is hold acknowledged to the DMA. So this is the process.
Hello, my name is Swarup Puri and I am going to explain the modes of direct memory access. Let's dive into the modes of direct memory access in detail. First type of DMA mode is burst mode. In this mode, the DMA controller takes control of the system bus and transfers a block of data without releasing the bus until the entire block of data is transferred. During burst transfer, the DMA controller performs consecutive read and write operations for a specified block of data. It utilizes the bus's full bandwidth, maximizing the speed of data transfer. This mode is especially useful when transferring large amount of data between memory and peripherals. It ensures efficient utilization of system bus and reduces the impact on CPU, allowing it to focus on other tasks while the DMA controller handles the data transfer. The second type of mode is cycle stealing mode. It is a mode that optimizes data transfer by utilizing idle cycles of the CPU. In this mode, the DMA controller steals a few bus cycles to perform a small data transfer. It takes advantage of CPU's idle time, effectively overlapping DMA transfers with the CPU's operations. This mode is particularly useful when the CPU's workload is not constant and there are intermittent opportunities to perform data transfers. The last type of mode is interleaving mode, also known as memory stripping. It is a technique that enhances memory access performance by dividing memory into multiple banks or modules and interleaving data across them. In an interleaving memory configuration, memory addresses are stored in different modules, allowing for parallelism in memory access. When a memory access occurs, the system can simultaneously access data from multiple modules, increasing the effective memory bandwidth. By distributing across multiple modules, interleaving mode reduces memory access latency and improves overall system performance. This mode is commonly used in systems with high memory demands, such as servers and high performance computing environments. But in some cases, it can introduce additional complexities, so it's important to consider the specific requirement and constraints of the system while implementing this mode. These modes of DMA provide different and efficient strategies for optimizing data transfer and memory access, enhancing the system performance. The choice of mode depends on the factors such as the nature of the data transfer, the characteristics of the system, and the specific requirements of the peripherals involved.
Continuing with the PPT, let's have a glance at 8237 DMA controller. 8237 DMA controller is not a detached component in modern microprocessors. It appears within the system controller chipsets. 8237 enables data transfer between memory and input-output system. 8237 speeds up data transfer by providing memory with control signals and memory address location during DMA transfer. It is a 4-channel device which can be expanded to increase the number of DMA channel inputs. 8237 is capable of DMA transfer at rate up to 1.6 megabytes per second. Each channel is capable of addressing a full 64K byte section of memory and transfer up to 64K bytes with single programming. 8237 operates in 4 different modes depending upon the number of bytes transferred per cycle and number of ICs are used. The 4 modes are single cycle transfer, block transfer mode, demand transfer mode, cascade mode. In single cycle transfer, only single transfer takes place and it is useful for slow devices. In block transfer mode, transfer of data takes place until time counter TC is generated or external signal is received. The demand transfer mode is similar to block transfer mode, but in addition to TC and external signal, transfer can be terminated by deactivating DREQ signal, that is the inputs from the 4 individual channel of DMA controller 8237. The cascade mode is useful to expand the number of channels beyond 4.
Hello, now we are going to talking about the advantage of DMA, that is direct memory access. First, reduce CPU utilization. When a peripheral device needs to transfer the data to or from the main memory, the CPU will traditionally have to manage the transfer by handling each data byte individually. DMA allows the peripheral device to bypass the CPU and access the memory directly, thus reducing the burden on the CPU and freeing up its resources to perform the other tasks. Second, faster transfer rate. DMA enables faster transfer rate between the peripheral device and memory as compared to traditional approach where data would be transferred through the CPU. This is because DMA can transfer a large amount of data in a single operation, reducing the overhead associated with the multiple small transfer. Improve system performance by reducing the burden on the CPU, improving the transfer rate. DMA can significantly improve system performance. This is particularly beneficial for high-speed devices such as network interface cards or video cards, where large amount of data need to be transferred quickly. Fourth is reduce latency. When a peripheral device needs to access the memory, traditional approaches require the CPU to interrupt the current task to handle the data transfer. This can introduce latency, leading the delay in data transfer. DMA can reduce the latency by allowing a peripheral device to bypassing the CPU. This is all about advantages. Hello, now we are going to talk about the disadvantage of direct memory access, that is DMA. First, this is a security risk. DMA can bypass CPU and system memory protection mechanism, allowing malicious devices to potentially access the sensitive data or system resources. Second, limited resources. While DMA reduces CPU utilization, it requires the additional hardware resources such as DMA controller, which can increase the overall cost of the system. Third, complexity. Implementing DMA requires the additional hardware and software complexity, which can increase the likelihood of bugs and error in the system. Fourth, limited compatibility. Some older peripheral devices may not support DMA, which limit their compatibility with modern systems that rely DMA for high-speed data transfer. Fifth, synchronization issues. Since DMA operates independently of the CPU, it may be necessary to synchronize the data wrappers between the DMA and CPU to ensure the consistency.
So far, we have covered all the topics. To quickly recap, I would like you to remember these key points. DMA is an abbreviation of direct memory access, and it is a method of data transfer between main memory and peripheral devices. The hardware unit that controls DMA transfer is DMAC or DMA controller. DMA controller transfers the data to and from the memory without participation of the processor. DMAC transfers the block of data to and from memory in three modes: burst mode, cycle steal mode, and interleaving mode. DMA controller is a convenient mode of transfer, and it is preferred over programmed IO and interrupt driven IO mode of transfer. These are some references. Thank you. That's all.